Hey everyone, ready to dive deep into some chemistry. We're going to crack open those physical science standards and see what secrets they hold.
Sounds good to me. It's always exciting to explore the fundamentals of, well, basically everything.
Exactly. And we're going to tackle a bunch today, like those three chemical bond types.
Yeah.
PSC.2.1, covalent, ionic, and metallic.
Yes, the forces that hold the universe together, literally.
Okay, so first up, covalent bonds. Those are what, like the super strong ones, where atoms, like, share electrons.
Yeah, think of it kind of like two best friends sharing their favorite toy. Those electrons are the toy and the atoms are the buddies.
I like that. So it's all about sharing is caring in the world of covalent bonds.
Right. And because carbon, the element that makes up, well, all living things, forms these strong bonds, it can build those really complex molecules that make life possible.
Wow. So life itself is built on sharing. That's kind of cool. But okay, what about ionic bonds? Are those like less about sharing and more about dot taking?
Not necessarily taking, but more like trading. One atom's like, hey, I don't really need this extra electron. Another one's like, perfect, I'll take it. They become oppositely charged, and boom, that attraction forms the bond.
Huh. Opposites attract, right. Just like in, well, everywhere, I guess.
Exactly. Think of it like table salt. Sodium gives an electron to chlorine, and bam, delicious ionic compound.
So sharing versus trading. I get it.
Uh,
What about metallic bonds then? Those are the ones that make metals all shiny and conductive and stuff, right?
yeah. It's like if we all got in a room and everyone brought their favorite toy, but instead of keeping it to ourselves, we just kind of let all the toys roam free.
Sounds like chaos to me, but I kind of see what you mean.
Yeah, kind of chaotic. But that's what happens with those electrons in metals. They're free to move around, which is why metals can conduct electricity so well.
Okay, that makes sense. So we've built molecules with these bonds, but now we got to name them. That's PSC 2.2, and it honestly feels like I'm learning a whole new language here.
Well, you kind of are. But luckily, we've got IUPAC, a system that gives us consistent ways to name and write those formulas for all those compounds. So H2O always means water, no matter where you are in the universe.
So H2O, that's like the chemical nickname for water. Love it.
Exactly. And we need to know these formulas for the next step, which is balancing equations PSC.2.3. It's like a recipe, only instead of ingredients like flour and sugar, we're dealing with atoms.
Ooh, baking. So if I'm making a cake, I can't just like toss in a random amount of flour and hope for the best, right? I need specific measurements.
Yeah.
Is balancing equations similar?
Yep. We've got to follow the law of conservation of mass. It basically says that atoms aren't created or destroyed in a reaction, just rearranged. So when we balance, we're making sure there's the same number of each type of atom on both sides of the equation.
Okay, so like making sure my cake recipe has the right amount of everything so it doesn't turn into a disaster. I can definitely relate to that.
Exactly. Balance that equation, and the reaction goes as planned. No leftover ingredients or unexpected results.
Got it. We bonded atoms, named them, and balanced them. We're basically chemistry wizards now. But things are about to get even more exciting with PSC.2.4 and the different types of reactions.
Right. We're talking about everything from those super fast reactions that make fireworks explode to that slow, gradual process of, iron rusting.
Wow, so much variety. How many types are we dealing with here?
5 main ones. Synthesis, where we're basically putting simple stuff together to make more complex things. Decomposition, where we break things down. Combustion, where things react with oxygen and release a bunch of energy. Then there's single replacement, where one element jumps in and replaces another. And double replacement, where it's basically a partner swap.
It's like a molecular square dance. All right, let's move on to the last standards, PSPSC.2.5 and PSPSC.2.6, which cover those superstars of chemistry, acids and bases.
Yeah. They play a crucial role in a ton of processes, from digesting your lunch to keeping the oceans healthy.
So they're more than just like sour lemon juice and bitter baking soda then.
Oh, for sure. Acids, like your lemon juice, they like to donate hydrogen ions, while bases, like that baking soda, accept them. And we use the pH scale to measure how acidic or basic something is, with 7 being neutral.
Right, the pH scale. Anything below 7's acidic, above 7's basic. So what happens when you mix them? Doesn't that lead to neutralization?
You got it. When they react, they neutralize each other, forming salt and water. You know, like when you add baking soda to vinegar, all that fizzing is the reaction happening.
That's how antacids work, right?
Uh,
The base neutralizes the acid in your stomach.
yeah.
Chemistry in action.
Exactly.
Wow, we've covered a lot today. We explored how atoms bond, how to name compounds, how to balance equations, and even delved into the world of reactions and acids and bases. It's amazing how it all fits together.
It really is. And this is just the tip of the iceberg, right? Chemistry's everywhere, and understanding these basics opens up a whole new way of seeing the world.
So now that you've got a handle on these basic principles, what else are you curious about? How does soap actually work? What makes bread rise? How do batteries hold all that energy? The world's full of chemistry mysteries, just waiting to be solved. Keep exploring, keep asking questions, and who knows, maybe you'll make the next big scientific discovery.
I like it.
And that's a wrap for our Chemistry Deep Dive. Thanks for joining us, and we'll see you next time.
See ya.
Bye.
Bye.